For Christmas this year, I made a video where we restored this ultra-rare IBM 5162 with a 5154 display. The 5162 is a real oddball AT, sold as an XT. For unknown reasons, it was squeezed in between the more modern 5170 and IBM's brand new lineup of personal system too. It came in a case looking much older than the 5170 and a motherboard with 0 wait states. With some minor overclocking, I think we can make this machine much faster than IBM's flagship at the time. There is a problem though. This IBM turned out to be a real Grinch. The system wouldn't post and wouldn't display any graphics on the screen. After I finished the restoration video, I did some basic troubleshooting. According to the diagnostics card, voltages and reset are okay. The postcodes indicates that this board fails the base 64K test. In the 5162, conventional memory addresses 0 to 512 KB resides in the two SIMs. I have replaced the fake bubble RAM with known good SIMs from another system, but that didn't help. I have also disabled these onboard RAM chips with jumper J10, just to eliminate one potential problem. To make sure my CGA card hadn't gone bad since I used it last time, I replaced it with an MDA card. Then this happened. We now have an error on the display. This arrow too points to faulty SIMs, but they are tested good, and so are the original SIMs that came with this machine. I did some reading at this point and found this page at -0 degrees. Quote, if your 5162 suffers a failure in the first 64 KB of motherboard SIMs, the resulting symptom depends on the type of video card and monitor. If MDA or CGA, you will see a 00 and so on. Well, exactly the error we have. If instead EGA or VGA is fitted, you will have what appears to be a dead motherboard. So that explains why we didn't get any graphics when we use this board with an EGA display. Apparently we can also get that error if the board is trying to test a different size of memory than it actually has. Since we have removed the battery, the CMOS should be cleared. And since we can't boot to a floppy, we can't change that setting either. So before we continue, I just want to make sure we have fully working BIOS chips. So let's get these original chips off the board. If one of the original EPROMs has bit rot, it could cause the error we have. So let's make sure that's not our problem here. I found the content of these EPROMs on -0 degrees. Okay, let's see if this made any difference. No, it just cycles between DD, FE and FF. And we're getting the same error. If you don't have a set of extra SIMs, you could move SIM 1 to the SIM 2 slot and a SIM 2 to SIM 1 slot. If you get a different address in the error, then you know one of the SIMs is bad. But in this case it didn't make a difference. Next thing to try is highly unlikely, but since we are going to upgrade the CPU, we might as well do it now and eliminate one more possible fault. Even if it's unlikely. The CPU is much faster than the original 286. Okay, let's do tests. And as expected, it didn't make a difference. But now we have one thing less that could be faulty. Okay, next we have these onboard RAM chips. So these are 512K to 640K. They are disabled with jumper J10, and they are not needed to post. And this is not where the error is pointing to. But I don't know exactly how that test works. So let's remove them and see if that makes a difference. So this too is highly unlikely to be causing our issue, but very easy to eliminate. So let's remove them anyways. Not the easiest chips to remove. They are squeezed in between the power connector and those two SIMs. By the way, this is the only switch on this motherboard. Facing this way for MDA graphics and facing this way for CGA. If you're using an EGA card, it doesn't matter how that switch is set. Let's do tests. But first I'd like to thank PCBWay for sponsoring today's video. Aside from making excellent PCBs, as shown in many of my videos, they also do CNC machining, sheet metal fabrication, 3D printing and injection molding. Perfect for vintage computer projects like this. Get an instant quote now at PCBWay.com. And don't forget to check out their shared projects page. That's where I have found many of the projects we have used on this channel. Thank you PCBWay for supporting this channel. And as I suspected, it didn't make any difference. Okay, that was all the simple stuff. This part of the video is going to be a bit difficult to record, because my capture PC is dead. So I've got my board here, and the scope up here. And I'm gonna have to use some good old-fashioned schematics printed on paper. Unfortunately, the scan that is available on -0 degrees is a bit too low resolution. I can read some of these letters and numbers, but not all of them. But let's just do our best here and see if we can figure this out. So here's SIM 1 and down here is SIM 2. And then we have all the address lines here. And they are going to this resistor pack here. And then to these two chips here. We also have gates here. There's some information missing here, but it's probably the same chip as this one here. U21. That is hooked up to... I can't read what the pin number here is, unfortunately. So these schematics are only partially useful. Needless to say, if you have a good scanner and these schematics, I'm sure -0 degrees are more than happy to upload a copy. So there is no easy way to access the pins directly on the SIMs. They are of course accessible underneath the board, but they're not labeled, so that would be a pretty hefty task to figure out which pin is which. So instead we could scope the signals at this resistor pack here. Same thing here, it's really hard to read, but I think it says AN1 and AN2. I can read some of the pin numbers. And here are our resistor packs. I think this is the best I can do. So these resistor packs are just straight through resistors. From pin 1 all the way down here to whatever pin this is. Okay, let's see what we will get on these pins. So if we turn the power supply on, we are getting what looks like pretty normal activity on pin 1 on that resistor pack. Same thing with pin 2, pin 3, pin 4, pin 5, pin 6, pin 7, pin 8. Those look like pretty normal signals. Let's check the other resistor pack here. Nothing on pin 1, nothing on pin 2. Pin 3 looks pretty normal. Pin 4, nothing. Pin 5, nothing. Pin 6 looks like a normal signal. Pin 7 and pin 8. So some of these seems to be unused. So if we look at the schematics here, yeah, I can't really read if that is AN1 or AN2. Unfortunately, I can't read the pin numbers here. The scan just isn't good enough. So that's not very helpful. The only thing that told us is that we have a good signal on some of the pins. But we don't know if all the address lines are good or not. Okay, so let's take a look at this LS125 up here at U21. I think the signal is coming out at pin 6 and pin 11. Let's find it on the board. Okay, here's U21. So we should see something at pin 6. At least I think it's pin 6. So 1, 2, 3, 4, 5. And this is pin 6. And it's just set high at 3.5 volts. Let's reboot and see how it behaves. Okay, it just goes high. So let's find what I think is pin 11. And here's pin 11. Let's boot. It just goes high and stays high at roughly 3.5 volts. Pin 21 here seems to invert whatever is coming in here. And I can't quite make out which pin it's hooked up to. It's just a blurry black mess. So that didn't really tell us much. So let's get back to this resistor pack here. Okay, so the signals are probably okay, hooked up to these 3 chips here. But since I can't read the pin numbers, I can't be really sure. Well, I think I can read what this chip here says. 47... No, I can't read this number here. And then probably 12. 47, and maybe 9, and 12. I guess we could check these. And then we have, I think, pin 7 and maybe 9 here. Let's check those pins. Okay, U107 is down here. So I won't be able to record it at the same time as the scope. Okay, U107 pin 4. That looks pretty normal. And pin 7, that looks normal too. And the next pin I think is 9, but I can't be sure. That pin looks pretty normal too. And the final pin on that chip is 12. And it looks normal too. So next we have U104 here. U104 is this chip here, so we can get it on camera. So pin number 4 looks normal. Pin number 7 looks normal too. Pin 9 looks okay too. And finally pin 12 looks fine too. Well, that didn't really tell me much. So let's test some chips that are connected to those SIMs. Let's start with this LS125 that goes high to 3.5 volts. That was a stubborn little chip with bent legs. Let's add some fresh solder to the remaining pins and see if it helps. It certainly did. When fresh solder is mixed with that old solder, it's much easier to clean out the through holes. Now let's get those pins unbent by heating them and then gently pushing on them. We don't want to pull that chip out with bent legs. It's not an easy board to work on. And it's also pretty crammed. I can barely get some hot air on those legs. So let's replace that chip with a 14-pin socket and solder those legs. Well, I don't have any LS125, but I've got some HC125 chips. So let's try with one of these. This is generally not okay, but let's see if we're lucky. And maybe it's at least good enough for a quick test. Okay, let's do tests. No, exactly the same behavior. No difference whatsoever. Okay, I wasn't too happy about that test. So I decided to desolder a proper LS125 chip from a working system and install it on this board now. Let's see if this makes a difference. No difference whatsoever. So at least we have ruled out one more chip. Okay, our next two suspects are these two F158s, U107 and U104. This is a bit more guesswork than I would have liked, but I'm not sure what else I could check at the moment. So I'll go ahead and put these two chips in sockets. Okay, same procedure as with LS125. With one difference, these are very close to the ISA slots, so I had to be very careful not to melt these slots when using the rework station. I couldn't find any 74 F158s, but I found one LS158, so hopefully it's good enough. This is a leftover, by the way, from the 640K hack in the 5155. You're gonna need one of these if you want to hack your XT board to take 640K directly on the motherboard. Well, they are not likely to be bad both, so I have reinstalled one of them in the socket and a brand new chip in this socket here. Okay, fingers crossed. No, same result. Okay, I swapped the two chips. Let's see if this chip is bad. No, no such luck. That chip is probably good too. Okay, my guesses were wrong. Back to basics. We have already checked the voltages in a previous video. Now let's check those pins on the 286. So, address line 0. Okay. Address line 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14, 15, 16, 17, 18, 19, 20, 21, 22, and finally 23. So all the address lines look good. So let's move to D0, D1 is fine, D2, D3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. Let's check that reset pin. According to the postcard it's okay, but let's check it anyways. Power off. And it briefly goes high, so I'd say that reset line is fine too. How about the clock? Yeah, clock is fine too. I'm still new to this scope. So where can I see the frequency? That's odd. We're getting 12 megahertz. So that can't be right. We should have 6. Yeah, something is wrong here. This board should run at 6 megahertz, not 12. How is this even possible? If we check in the datasheets, the pin that's marked CLK, this is our system clock output. Clock output is used by the processor. The frequency of the clock output is twice the processor's internal clock frequency. So is it supposed to be 12 MHz at the CPU? Oh crap, I thought we were onto something here. But that clock speed is supposed to be twice the speed the CPU is running at. So back to square one. Okay, here's my next theory. According to -0 degrees, we could get this error if the board is trying to check different size of RAM than it actually has. I don't know what the default value in the BIOS is, but what if these machines were sold with 640K standard? But we're only running 512K with these two SIMs here. I have tried to boot this machine with this extra RAM on board, but what if one of these original chips is bad? Then the board still has less than 640K. And we obviously can't change those settings, because we can't boot from the setup disk. Okay, so this is a mix of 41 256s and 4064 chips. So let's replace those chips. I can hear you guys screaming, "Stop! These are empty branded chips." Well, I pulled them out of a working system. And just to make sure, they are also freshly tested in a Commodore shortboard. So they should be good enough, at least for this test. I will of course replace them later, because I want to make sure this isn't going to be a bottleneck when we overclock this machine later. And these Oki branded chips here, they are freshly tested in the XT. We also need to activate those RAM chips with jumper J10 here. Okay, fingers crossed. No, that didn't work. Crap. So that wasn't the issue. Well, I just remembered an old project with a similar fault. I think it was a 486 system that hanged in posts, and that system had a bad SIM slots. So the next thing to do is to inspect these SIM slots. So to check those SIMs, let's open up a Christmas present here. This was sent in for free with a coupon, so you can get 10% off if you're interested in buying one of these. So this is a Elecleave 8-inch 4K digital microscope model EM4K. Let's use it to inspect those SIM slots. So first off we have a manual. Looks pretty extensive and well made, with color pictures and all. That is getting rare. So bonus points for that manual. Next we have what looks like a diopter. It says UV, so maybe that's a UV filter. It's actually not listed in the manual. We've got a power supply and a light barrier and an actual microscope. Let's peel that off. Very nice and large display. We seem to have some built-in lights. That's very useful. We've got a memory card and some connectors at the back. Bunch of cables. A remote control and an adjustable bracket. A cleaning cloth. And a very nice and large base plate with some built-in lights. I'm not going to read the manual. I'm just going to guess. So I'll just screw this bracket in and unscrew these two screws here. This is easy enough to guess. And lock it with these screws. Okay, power hooked up to the microscope. And there's a cable going down here to power these extra lights. Okay, let's turn the power on and adjust the focus. So in my experience, good lighting is everything when it comes to microscopes. Yeah, that looks pretty good. Let's see how close in we can get. Yeah, check out these chip legs. They look just fine to the naked eye. But this close in, they look really crappy. Okay, so it's definitely working. Let's check those SIM slots. Yeah, this type of slots aren't great. They have given me trouble more than once. Let's remove those SIMs and get the board under the microscope. So with the lens this close to the board, we are of course going to get a very shallow depth of field. But the interesting thing here are these tabs here. Well, my capture PC is still dead, so I'm gonna have to record the screen. Not ideal, but this should be good enough so we can check these tabs and see if they are all okay. Those are good. They are sort of like hooks. Everything looking good so far. They look clean to the naked eye, but as you can see here, there's some dust. But a tiny amount of dust shouldn't cause the problems we have. So let's check the other side. Yeah, with this kind of magnification, tiny piece of dust looks enormous. I don't think this is going to cause any problem. But let's remove it. Well, this one actually has what looks like corrosion on it. What is that? No, that was just some loose crap. I ran out of canned air, so I can't blow that dust off. At least not today. Okay, that slot is fine. Let's check the other one. All looking good so far. Well, aside from some dusts, these connectors look fine. Let's check the other side. I'll probably skip ahead here, not to bore you. But I am of course checking every pin. And that was the last one. And let's say those slots look fine. Let's have a look at those original SIMs under the microscope. So this huge thing here is a tiny pad on the SIM. And here you can actually see where it made contact with the slot. I'm gonna check all the pads, but I'll do it off camera, not to bore you. By the way, I was incorrectly referring to these original SIMs as bubble RAM. And they certainly look like bubble RAM, but they're not. These are just lookalikes. I don't know why IBM designed them this way, but these are just regular 256K 150 nanosecond SIMs. One thing I didn't think to test was to try the board with these original SIMs after I had cleaned those slots. So let's just quickly clean these pads off and do a test. In case our board is picky with SIMs, I'll just use a scratchy pen and clean those pads off. Better wipe them with IPA, because that scratchy pen leaves tiny particles. Okay, the original SIMs reinstalled. And no, that didn't make a difference. Okay, next up I did some reading. And I found these guys here on -0 degrees. These are super soft landmark diagnostic ROMs. Let's see if they can give us a clue to what's going on with this board. I have switched to CGA because I think there is a compatibility issue with MDA graphics. So let's flip that switch and see what this will tell us. Okay, we're getting some beep codes. And the screen is flashing. Let me check what this means. Oh, we're getting some partial graphics. And it stopped beeping, I was about to say, but then it started to beep again. Well, it's doing something, but I obviously can't see what. And the diagnostic card is stuck at 0, 1. Okay, if I count here, it seems to stop at the 7th test. And according to the manual, that is U36 8255 parity detected passed. And the next line is 16K critical memory region. So I'm not sure if this is pointing us to the first 16K of memory, or if it's showing a bad U36. Well, in the manual there is a picture of the screen, but that is for an XT. So let's check those beep codes instead, because this is of course an AT. So I'm not sure how to read these codes here. It says high, low and short. So should I count those as 2 high lows and then 1 short beep? In that case it's pointing to the same 16K critical memory region. Or maybe that should be counted as 4 high-low beeps and 1 short. In that case it's pointing to system memory at address 0. So we've got some funny graphics, but these diagnostic ROMs only points to the same issue as we already know we have. Still those damn sims that are tested good. I decided to reinstall the original EPROMs, and now we're getting a flashing screen with characters. This probably isn't much of a clue, but it makes me wonder if that CGA card is okay. I haven't marked it, so I can't say for sure if it's tested. Okay, I checked and my other CGA card is in the 5155 at the moment. Unfortunately, I don't have time to pull it out for this week's video, but I will of course swap that card and check if this card is okay. But that doesn't really matter much at the moment, because I think these diagnostic ROMs are pointing us to the same issue as we already know. Those two working sims. Okay, this video is going to be slightly late because I just found a picture of the screen with that software running on a 5162. And row 7 is pointing to the 8237A DMA controller. I don't have a spare chip, so I'm gonna have to borrow a chip from the 5150. Since I'm running late now, I'm going to pull that chip off camera.
So much later that the old narrator got tired of waiting and they had to hire a new one.
Okay, 40-pin chip galore is finally done. There isn't as much information about these boards as for the PC and the XT. So this board has 2 of these chips, and I don't know which one is DMA controller 1. So I decided to pull both and install sockets. So I'm going to install the chip from the 5150 in U9 and the original chip in U8. That was a lot of bent pins to unsolder. I haven't unsoldered this many pins in one go since the early days of this channel, when I did a lot of Commodore 64 stuff. Okay, fingers crossed. Okay, we're getting the same crap on the screen as before. Let me switch to MDA graphics. Okay, let's try this instead. And as we expected, still the same error. That means it's not U9, but we have 2 of these 8237s. So let's pull the original U8 and install the original U9. Okay, fingers crossed. Let's see if it was U8. And no, it wasn't. Crap. That sucks. Okay, our next suspect is one of these delay chips here. I haven't checked which one is which yet, but apparently if that chip goes bad, the machine would give us that error that we have. So that might be our faulty chip. So next I will go through my stuff and see if I can find one of these chips. So this project is far from over. Hit the bell icon below and set it to all if you want to join me in the next video. And now is a good time to watch the video where we restore this Grinch. I will end this video by saying thank you to my patrons. I appreciate your support. If you want to support me too, consider becoming a patron. Patrons get early access whenever possible. You can also support me with a like and a comment. If you are a regular viewer, consider subscribing to this channel. Thank you for watching. I wish you all a happy new year. See you next week.